back. Welcome everyone to the TE Academy study season. We are live with the third session, Shermin, Voshmgir, a structured approach for crypto founders, protocol designers, and token engineers. We'll discuss the token design thinking framework today again, going over a case study. So this will be a hands-on practical session. Excited for that. Before we start, I have some updates for you guys. Hello, everyone. Welcome back in the session. Glad to have you on board again. All right. One more note. In case you haven't heard of the EthCC ticket giveaway, you probably know that at this year's EthCC, we'll have, again, a token engineering track day, July 10th, a full day of token engineering talks. And we know that it's quite hard to get a ticket for EthCC. The ticket sales rounds are sold out very quickly within minutes. And that's why we are running an EthCC ticket giveaway for our community members. So you have the chance to win a free ticket worth 500 euros each via recommending our newsletter to your friend. Let's spread the word about token engineering content. You can check out this QR code. I'll drop a note in the chat as well. Spread the word about the TE Academy newsletter and win a free EthCC ticket. Okay, I hope to see you all in Brussels. But for now, I'm excited to continue working on the token design thinking framework with Shermin. Shermin, welcome back. Glad to have you in the session again. The stage is yours.
Thank you. Hi, everyone. So thank you for your patience. This is session 3. Today we will be focusing, last time we looked at the kind of design thinking framework from a theoretic perspective. We walked through all the questions, and there are many. And I hope you have a good overview of the scope and depth of kind of design questions that need to be resolved before being able to go into implementing a token system. Today, I would like to use the time to analyze the Bitcoin use case. We selected the Bitcoin use case because it's the one that most people know, or they at least think they know it. But then very often they find out that they have many people have limited knowledge about Bitcoin, the network, the currency, etc. So and I really think that you need to understand the Bitcoin network and the stakeholder structures and the cryptoeconomic system and the economic incentives, the pros and cons of the economic incentives before moving on to other use cases, because in the end, it all started with Bitcoin. All right, so I'm going to quickly share my screen with you. Just give me a second. All right, so when we talk about Bitcoin, very often maybe not we, but in the general public, when the media talks about Bitcoin, but also actually in crypto, the focus is mostly on a Bitcoin, the currency, and less on Bitcoin, the network. But the currency wouldn't be possible without the network. And if you remember, in our first session, we went through kind of the use cases of Web3 use cases, and we looked at this slide, and basically Bitcoin is more obviously than the currency. It is a publicly maintained or collectively maintained payment network, and as such represents something like a decentralized, or what some people would refer to as a decentralized autonomous organization, which is operated by a distributed network of autonomous stakeholders. So we also talked about the fact that Bitcoin was revolutionary because of the introduction of proof of work. which introduced this novel type of coordination over the internet in the absence of intermediary services guaranteeing trust. So trust is generated by math rather than by legal contracts like in traditional organizations. Individuals get incentivized. Individuals participating in the upkeep and maintenance of the network get incentivized with network tokens, with the currency of the network, for contributing to network operation and maintenance. So very simplified token flow. Basically, anyone node operators that contribute to the network here. The mining node operators in this case can add transaction to the ledger via the process of proof of work, and we will look at that in more detail, and can receive newly minted bitcoins. Miners also validate Bitcoin transactions and are paid in existing bitcoins for each Bitcoin transaction that has been validated in their block. So here, this is the symbol for the miners. Now, miners who earn newly minted Bitcoin tokens can either hold on to these tokens or exchange these tokens for other currencies on an exchange. These exchanges can be used by other people to buy the sold tokens, these newly minted tokens that have been sold, the ones that have been sold. So I can either mint myself or kind of become a contributor myself and earn newly minted Bitcoin tokens myself, or I can become a user via buying Bitcoins on an exchange against fiat currencies or other cryptocurrencies. And once I did so, I can now hold on to the Bitcoins or spend them or send them to someone. And every time I do, I activate the whole Bitcoin networks gets activated for validating, propagating the transaction and validating the transactions, participating in and adding the transaction to the ledger. And then this whole circle recurs again. Briefly, if we analyze the most important properties of Bitcoin, we start with the purpose, as we mentioned last time. So the intended purpose was to create peer-to-peer money. We will see throughout the session that the intended purpose is not quite the realized purpose. We could refer to it rather than peer-to-peer money. Many people refer to it as peer-to-peer gold for the lack of price stability. The token is minted upon proof of work. It was not pre-issued at the token sale, but new tokens are minted upon proof of work. And the token is designed to be fungible in theory. We will see that in reality, because of chain analysis and the interaction with the real world and the limited privacy aspects of the current design of the Bitcoin network, tokens can be tainted, their history can be tainted, they can be frozen, and in this case, the fungibility is in practice limited, while in theory it is designed to be a fungible token. The token is also designed to be transferable. It has unlimited transferability. That's the whole point of a currency. Because it's a currency, there is a supply policy. We will analyze the supply policy a bit later. It is rigid. It cannot be changed and is fixed to 121 million. The rights attached are basically property rights. It represents an asset that has a value, and the value is determined by the exchange rate or the price, supply and demand on the markets. But it also represents an access right to use the network and to pay for network services. There is no expiry date attached to the tokens. And privacy is limited because of the pseudonymous, so identities are pseudonymous, and well, depending on which at which point in time we look at Bitcoin, depending on the protocol upgrades, there can be more privacy by design. Why is it important to understand Bitcoin as a network, as an economic system? It's a crypto economic system. It's an economic system because it has its own internal currency. We will look at the economic design. In this case, the currency is Bitcoin, but it's obviously also a social system because people opt into the network as with different roles to be node operators, different types of node operators, mining node operators, full node operators, or only users of the system by owning Bitcoins. And this is not only an economic system and a social system, but as we will see in our analysis, throughout time, the system has evolved beyond what the original founders, into a direction what the original founders might not have anticipated because of the nature of complex social economic systems. These things happen, and we will look at some examples of the complex nature of these systems, or of Bitcoin in particular. So if you remember, last week we walked through the question set of this design thinking framework, and the first question was, what is the purpose of your system you want to create? So to repeat it, we stated it before, and it is stated in the white paper that Satoshi released in 2008. The purpose of Bitcoin was to provide a peer-to-peer electronic cash system that resolved the double spending problem over the internet in the absence of traditional financial intermediaries, and with lower settlement fees than the current financial system. So if you remember last time, I urged you to try to put, if you create a token system, try to be very specific and try to put it in one sentence, even though it's a long sentence, but here it is very clear what they're trying to do. Now, that was the purpose. The next question that is important when you design a system is, what are the political principles? So it is, in hindsight, it's hard to say because of the fact that Satoshi's identity is unknown. We don't know whether it was one person or a group of people. We can only speculate about the real motivation behind writing this white paper and creating the code based on the information trails that we have available in the mailing list and similar online sources where Satoshi was active, and the first co-developers who helped Satoshi develop the protocol were active. What we can say based on these information trails is that one of the core principles was disintermediation, decentralization, and censorship resistance of state authority. And the censorship resistance of state authority was a result, wasn't really, at least my impression when reading through the documentation, Satoshi didn't seem to be a crypto anarchist, but more a realist. Bitcoin didn't fall out of thin air. It built on decades of science and research and development in trying to create peer-to-peer electronic cash systems, or some kind of electronic cash systems. And all the people since the 80s who'd been working on such systems always had kind of a central coordinator. There were sometimes companies, and sooner or later, these systems were censored under banking license laws, privacy laws. Some of the people were put in jail. And this is probably one of the reasons why censorship resistance was such a big value when creating Bitcoin, or among the first Bitcoin core developers and adopters. Open source, public and permissionless infrastructure, that's a different, the next political principle. The source was, the code was open source. And the idea was that anyone can participate in writing code, in contributing as a node operator, and in using the network. So public and permissionless. Now, this next one is a bit controversial. Many early Bitcoin enthusiasts propagated the idea of the immutability of the code, because But this was never mentioned in the source code. What was in the white paper or in the original kind of online sources where the people were chatting about how to design the system, what was discussed was the fact of making transactions irreversible, but for a very pragmatic reason, of making the system less manipulation resistant. And it was not kind of a dogma to make the transactions irreversible for dogmatic reasons, but for very practical reasons of creating peer-to-peer electronic cash in the absence of intermediaries, like having to avoid the double spending problem, basically. So that had priority to making certain transactions reversible, and it was a very highly contentious topic in its time, by the way. But later on, many people made it a dogma. And so this is also interesting to see how these social systems evolve over time and how certain narratives change from what the original founders intended and what later adopters then the storytelling that happens with later adopters. Privacy obviously was always an issue, but privacy was limited in the beginning, and Satoshi proposed many workarounds. He or she or they knew that the privacy solutions, the proposed privacy solutions of version 1 of Bitcoin were insufficient. Privacy was important, but the idea was that eventually people would work on these solutions before the real Bitcoin protocol would go online. But that, of course, never happened because the test network that was deployed became the main network over time. So I'm not going into these details because I already discussed this. I will share these slides with you later after this session, and also put it on my websites for those people who are not on the Discord channel. The challenge to we now know what the purpose was and what the political principles were, but the real functional challenge that needed to be resolved was how could one create a payment network that was collectively maintained in the internet where people didn't know and trust each other. So how could untrusted internet actors collectively agree on the truthfulness of a transaction? How could they avoid the double spending problem in the absence of intermediaries? And as I said before, academics and practitioners had been working on this question for decades. Many forms of private digital money in general and cryptographically secure peer-to-peer money in particular had been experimented with over various evolutionary stages since the 1980s. But before the emergence and the deployment of the Bitcoin network, no one had really resolved the double spending problem over the internet. To resolve this, certain functional design questions were made. And at the time, it was hard for people to grasp. And I think sometimes now in hindsight, it makes more sense, but because we know how to explain it. So the first design decision was that money could not be represented by a digital file, but kind of that digital money that they wanted to create needed to be an entry in a collectively maintained ledger, and every node in the network would have the same copy of the ledger. Because as a digital file could be spent, could be simultaneously in a client server network or client server system architecture, digital files can be copied. So it couldn't be represented by a digital file, but just by an entry in a ledger, by kind of an accounting mechanism. Identification, another design question was how to create identity systems and password management in the absence of central coordinators. So the decision was to use public key infrastructure, but not centralized public key infrastructure, but decentralized public key infrastructure where token holders would be identified through a blockchain address, and with their public and private key could generate digital signatures to authenticate themselves. So basically, without needing this allowed Bitcoin's creators to really create a system where there is no password management, centralized password management, and address management based on mathematical functions. The private key is randomly generated, and the public key is derived from the private key, and the blockchain address is derived through mathematical functions based on an algorithm that everyone can download and verify, is derived then from the public key. So this is how they distribute the identification function and digital signatures. The biggest, of course, game changer was the solution of having distributed consensus and time-stamping through the mechanism of proof of work. We will look at that in just a bit. Then another very important design function was the 10-minute block creation interval, the block reward, and the economic security function tied to that block reward. So I explained the identities and that Bitcoins are not digital files. I will share the slides with you, but we don't need to read through everything again. So just to make sure that you also understand why, who the stakeholders are later, we need to go through this. Distributed consensus in a payment network means that the greatest challenge was that in an anonymous network of participants, any malicious network nodes can compromise the system in the absence of centralized parties securing the system. So the question, as previously mentioned, was how could a distributed network of anonymous actors reach consensus about which data is correct or incorrect and which process is true or false? And this is in distributed systems, this is referred to the Byzantine's general problems, okay? And before Bitcoin, no one had achieved a fault-tolerant and attack-resistant coordination mechanism. Proof of work was this groundbreaking game changer to reach distributed consensus. Here, the challenge was how to verify the order of transactions in a peer-to-peer network so that the same unit of currency could not be spent multiple times by the same person. For that, kind of proof of work was very useful because it guarantees a computational proof of chronological order of transaction Bitcoin transactions that quickly becomes computationally infeasible for any attacker to change. So the way it works, and I'm sure that most people of you know, the way it works that if I send Bitcoins over the network to someone else, my probably light node or full node broadcasts the transaction to the network. Other nodes collect the transactions and start my transaction and other transactions that have been propagated in the network, and they start participating in the race to resolve the proof of work puzzle to find a certain mathematical value. This is very energy intense. The winning node, the fastest node to do that, gets to write all the collected transactions to the next block. And this block data is then broadcasted to the rest of the network, and all other nodes in the network collect this data. They verify this data, this block, and they get to accept or reject this new block. So this mechanism ensures that all independent nodes have the latest version of the ledger and can verify the truthfulness of transactions, while no single party can unilaterally control it. Another design principle was the 10-minute block creation rule or design. This was important because in a distributed network where a sender of Bitcoins communicates the transaction with the rest of the network, and this is a global network of computers, there are network latencies and potential network delays. Satoshi needed to make sure that the transaction information gets propagated to as many nodes as possible across the globe. So it's actually decentralized, and so that other nodes can receive and validate them in a secure way, even smaller computer or not so fast computers or computers with more latencies to the sending node. And the solution was to artificially prolong the process of creating blocks to a 10-minute interval. Longer block intervals would, in theory, guarantee higher levels of security, as more nodes would have the chance to participate in the mining process. But this would make the network harder. Yes, it would make the network harder to manipulate, but also make the network much slower and much less scalable than it already is. Shorter block intervals might favor participants with access to higher efficient or bigger computers to participate in the network, but not the smaller computers or less powerful computers. The block reward, kind of the economic had two functions. Of course, was intended as an economic incentive for network nodes to invest into hardware and electricity and to participate in the process of proof of work. But the block reward has also another interesting twist to it, or distributed policymaking or execution twist. The node that gets to write the next block of transaction gets to mint these new kind of the tokens that they get awarded are minted in this new transaction. So minting is decentralized. I think I mentioned it briefly last time also. The mechanism is designed in a way where instead of a central authority issuing kind of the currency of a nation, minting is executed each 10 minutes, each block by a different node who got awarded or won the race. And this mining node, upon a proof of work, gets to create the new block. And in the first transaction, which we call the block Bitcoin-based transaction, registers the newly minted Bitcoins, which then have to be validated by the rest of the mining nodes. So the minting function is also decentralized this way. The economic security function, so proof of work has the security function and was designed with the purpose that finding the correct hash value, this mathematical puzzle we refer to, requires computational work in the form of processing time. And this is intentional because it's an economic measure to deter network attacks. So if a dishonest node were the fastest computer to find the hash, but did so for a block that breaks the rules, the rest of the network would not accept their block of transactions. The cheating miner would not receive the block reward, even though they invested in hardware and in energy. And through this backdoor of sunk costs of infrastructure and electricity, network attacks are made prohibitively expensive. Unfortunately, because of the computational intensity, the Bitcoin network also consumes large amount of energy, and it doesn't scale well. And this now led then to alternative consensus mechanisms, but this is not the thing we want to discuss today. Okay, so this is in a nutshell kind of the most important design principles of the mechanism of how Bitcoin works. And obviously, this books have been written just about the mechanism of Bitcoin. The technical intricacies are not what we're interested in today. What we're interested in today is to understand the kind of social and economic dynamics that were designed into the network and that unfolded over time. So if you remember, we have this governance feedback loop. We can take this governance feedback loop and of decentralized networks or DAOs and use it to analyze also how Bitcoin evolved over time. So if we think back to 2008 and 2009, in 2008, Satoshi surfaced for the first time in an online forum on the financial cryptography mailing list, and shared the ideas of Bitcoin in the form of the Bitcoin white paper, and discussed it with a group of people who were interested in financial cryptography, hence the name of the list. The group was still small. It was Satoshi and maybe more than a handful, but a limited number of mostly researchers and developers who had been discussing for years similar topics. And so that was end of 2008. So on this financial cryptography list, the group was still small, and this group of people discussed kind of how these ideas of the white paper could be implemented into code. And a few months later, maybe Satoshi already had a sample code, maybe not, we don't know. It took a few months longer, and beginning of 2009, Satoshi released the source code on the same mailing list. And I think it was also modified, eventually modified, and the protocol version 1 of the Bitcoin protocol, or actually the test, was deployed with the intention of creating a test net, which eventually became the main network because it never really left the test network stage. So the Genesis block was mined, and this Genesis block and this initial code, this algorithmic administration of governance, really set the initial conditions, and including all the unintended consequences, which we will analyze now, that unfolded over time. This protocol was downloaded by the first participating node operators, and they started to download the protocol and start mining Bitcoins. People were sending Bitcoins from one wallet to another. The group was really small and started to test the network, and the assumptions worked. Eventually, there were obviously ideas how to improve aspects of the protocol, and the small group of people started to become bigger. Node operators and protocol developers. In the beginning, this group of people, the protocol developers, were also node operators, and with node operators, and these nodes performed all function in the system, including mining. They suggested eventually protocol changes. There was the social governance process, and until there was a consensus about how to create version 2 of the protocol, which was deployed, and then et cetera, et cetera, et cetera. So this feedback loop goes on and on as the group became bigger and bigger with time. Now, if you remember in our design thinking session last time, we said that the first thing that helps, that is important to do once you define the purpose and the political principles and the functions that need to be fulfilled in your network for whatever purpose your network has, is to identify potential stakeholders and group them according to, for example, internal stakeholders and external stakeholders, or policymakers and other stakeholders, those who can write policy or vote over policy changes, and those who don't. And there are many categories. We're not going through all of them. Here we have the group of internal stakeholders, and the policy, those who can change the policy have a different icon than those who cannot change policy directly, at least. So we have the mining node operators, also called miners. We have today the full nodes, We will see later that in the beginning, the idea of there was no distinction between mining node operators and full node operators that emerged over time. Obviously, we have those who develop the protocol, who contribute with code propositions of how to improve the protocol. They can also operate a node in the network, but they don't necessarily have to operate a node in the network. In the beginning, these roles, everyone was doing everything, but eventually these different stakeholder groups emerged. Then we have the users. Users are usually those who only own Bitcoins. They might have a light node or a full node, or even maybe operate a mining node, but they basically own Bitcoins, and they manage their Bitcoins in their wallet, and they might send Bitcoins over the network. We have the hardware producers. They are very important, an important stakeholder in the network, because they influence the conditions, the economic conditions of mining. And we have wallet developers who create the interface for kind of the blockchain client, in this case, the Bitcoin client. On the other side, we have external stakeholders, or stakeholders at the edges of the Bitcoin network, on the periphery, that influence in one shape or another the kind of conditions of the network over time. External policymakers, they didn't used to be very care about Bitcoin in 2009. Bitcoin was still a fringe phenomenon. Today, policymakers all over the world on a local, national, international level have more and more explicit cryptocurrency legislation, crypto legislation, Web3 legislation, smart contract-based legislation that influences also the economic conditions of the Bitcoin network, and whether or not it is profitable to invest into Bitcoin, to become a miner, etc., etc. At the fringes, you also have the exchanges, the merchants, who make or break the system, are the kind of market makers, exchanges that accept Bitcoin and that trade Bitcoin, merchants that accept Bitcoin, and nation states that maybe prohibit Bitcoin, or like in the case of maybe Panama, even make it their national currency. So how a nation state accepts or rejects Bitcoin as a currency, but also the payment network, the operation of the payment network influences the network dynamics. You have non-human institutions, other Web3 protocols, the formal protocol, hashing algorithms, if they change, if they improve, if there is developments in quantum cryptography that could break certain hashing protocols, that would also influence the system from the outside. And these are not humans, but kind of protocols or non-human institutions that influence this network, internet availability, electricity market, etc. And obviously also other Web3 protocols, the rest of the crypto landscape, and what happens there in terms of innovation, in terms of competition, is relevant and influences the economic dynamics of social and economic dynamics of the Bitcoin network. I'm just going to look at the time. Okay.
Okay. So we're 40 minutes in.
Yes. So maybe a bit more in detail, because looking at the stakeholders, as you know, is very important, because we need to understand their role, their functions, and based on their functions, they would have certain permissions, rights, or powers in the system. They would get rewarded, but also have certain obligations in the network, and these obligations can be explicit, as, for example, because they can come with direct or indirect penalties attached. For example, in proof of stake, it's not relevant here, the penalties are very explicit. In Bitcoin, in proof of work, they're more implicit, and we'll look at that. So mining node operators are probably the most important, because without them, we don't have new transaction blocks. They emerge over time as independent node operators that were distinct from full node operators. Any mining node operator also needs to operate a full node. And he also needs to manage the full state of the ledger. But full node operators emerged later who don't do mining. Mining node operators, they secure the network to avoid the double spending problem, what we discussed before. They collectively, they collect the transactions, participate in the proof of work race, they broadcast transaction blocks, they verify new blocks, and they issue the block reward, if they get to issue the block reward, if they were awarded, if they were the winning miner, and they can vote on protocol upgrades by adopting a new protocol or not adopting a new protocol. That means that if you analyze these functions, what kind of permissions, rights, and powers do they have? They have a lot of executive powers in the network, basically the executive power to write transactions to the ledger. And they have voting rights over protocol upgrades. You could argue that they have voting rights over accepting also new blocks to the ledger, about the validity of a new block. Yes, also that. The reward is economic in terms of the block reward. They receive newly minted Bitcoins, but they can also receive transaction fees from, and they collect these fees. So the block rewards are collected. They are kind of defined in the protocol, and the transaction fees are paid by the senders of Bitcoins directly to the miners that create the block. They have the obligation to be honest, otherwise they have the sunk cost of hardware investments and energy investments. As I mentioned before, full node operators were not envisioned at the time of writing the Bitcoin white paper. They emerged over time. Why? Because operating a mining node became more and more, you could do it in the early days from a laptop or a desktop computer, but as the difficulty rate of the network went up, and a specialized hardware started to be produced for being more competitive or being able to compete better in this race of proof of work. Operating a full node became much more expensive, much less inclusive, and I think that's also a very important aspect in terms of decentralization. So many people could not afford or didn't want to afford to participate in the process of mining, but they still would operate a full node. Full node meaning that they would they would have to manage the whole state of the ledger on their computer, and with that could validate new transactions as they were being added or are being added to the ledger. So they would not rely on other people's data, but they could verify based on their own data if transactions are valid. The function of a full node operator is to operate a Bitcoin client that also contains all historic Bitcoin transactions. The permissions are basically because they were not intentionally designed as an independent stakeholder, they don't get rewarded for their validation kind of services. So operating a full node gives you the power to be independent and verify ledger transactions without having to rely on trusted third parties, but you don't earn anything for doing so. And you don't get, as a full node operator, you don't get to vote over protocol upgrades. unless you coordinate as a full node operator with other full node operators over what is called a user-activated soft fork, or a user-activated soft fork, not a minor-activated soft fork, obviously. User-activated hard fork should be here. This is the wrong. I'm going to correct this. The rewards and the obligations, yes, they don't get rewarded with Bitcoins for their contributions to the network. Bitcoin users, they own the currency and use the network to pay with Bitcoins. They generate, their function is to generate demand for the currency and network services. And their function is to pay transaction fees to miners. This will become more and more important as the block reward decreases over the years. The permissions that they have in the network, basically, well, they own, as a Bitcoin owner, they have the property right to Bitcoins. They are the only owners, and nobody else will be the owner. This is the whole point of validating ownership of Bitcoins at a given time. They have access rights to the Bitcoin network to be able to use the Bitcoin network and pay for network fees. They don't have direct voting rights. As I mentioned before, only mining node operators have direct voting rights. If a user operates a full node, they can participate in the user-activated soft fork or hard fork. Yes, they have the obligation to pay fees for sending Bitcoins to over the network, and they pay these fees to the miners directly, but also to, if they operate a third-party wallet, to a certain percentage, in most cases, also goes to the wallet provider. They have the obligation to safeguard their own private keys, or else they will lose access and autonomy. They could, of course, Bitcoin users over the last years have more and more outsourced their private key management to third-party services like centralized exchanges, which in the end has led to a re-centralization of Bitcoin, because if you don't control your private keys, you don't control your coins. It's not peer-to-peer money anymore. It's basically centralized exchanges becoming the new banks. And unfortunately, that has been a reality, which we will talk about a bit later too. Wallet developers are another kind of stakeholder group that emerged over time. The Bitcoin protocol itself was not user-friendly. More user-friendly wallets needed to be developed for people who don't know code, to be able to receive Bitcoin and send Bitcoin without having to operate command line. No command line, no blockchain code to communicate with the network. So over time, different wallet developers evolved who offered client services to the users. So, yeah. Their role was to develop and define the user interface. And the function is to provide application-based usability services. As for permissions, since Bitcoin is a permissionless system, anyone can develop a blockchain client. Wallet developers have a lot of power over user adoption. And they also have power over, depending on how the client is designed, they kind of can manipulate the Bitcoin users to pay more or less fees depending on how the user interface is designed to make them is visually designed to maybe incentivize them visually to pay more fees, and so they have some market power there. They don't have direct rewards. They're not rewarded with any Bitcoins for contributing with their very important services to the Bitcoin network. they have to comply with the protocol rules. Otherwise, their wallet service is not compatible with the network and nobody will use it. But they don't get rewarded with Bitcoins. They can get only paid via transaction fees by wallet users if the wallet users are willing to pay those transaction fees. So protocol developers, they make policy proposals and code implementations. They make the contributions for what we refer to as the computational constitution of the Bitcoin network. In theory, anyone can contribute. In practice, so it's very often argued that Bitcoin is permissionless. Anyone can contribute with code. Yes, this is true in theory, but in practice, very little people have the coding skills and the higher mathematical skills to understand the code and to participate. Either they don't have the know-how and or they don't have the time. Because participating, understanding the code that has the code base that has evolved over the years, and the body of code is very big. Even for people who used to know to read the Bitcoin code base a few years ago, if they didn't keep at it, it's really hard for people to be up to date about all the intricacies of the code. Unfortunately, fortunately, Bitcoin was designed based on the open source culture, where people would contribute for code for free for the merit of contributing this code. The problem is that as it becomes more and more specialized, and since there are no direct rewards, fewer and fewer people are contributing, and as it is becoming also more time intense to be able to contribute with meaningful code propositions, less and less people have the time or the money to make protocol improvement proposals and contribute with code. And this has led to centralization of code development or sponsorship of code development by private interests. So this is actually an issue. Hardware producers were not relevant at all in the beginning, but now they a monopoly of a handful or maybe even only one hardware producer dominate the market, who produce all of the mining rig hardware. They develop the chip logic that interacts with the protocol, and they create the physical components necessary for mining nodes. They have the market power over hardware costs and chip logic. They influence boundaries of consensus mechanism, or the boundaries of the consensus mechanism, and the economic design. They have indirect policy-making power to influence protocol development because they influence the cost of operating a mining node. They get paid by mining node operators, or because they have this kind of market power, or they're so centralized, it is often cheaper for hardware producers to operate a mining node than for non-hardware producers to operating mining node, because they have to pay a premium on the hardware and have less profit margin. So hardware producers have the incentive to become mining node operators have this competitive advantage. So there is this re-centralization tendency through the backdoor of centralization of hardware producers. Exchanges and banks, they're very important because they are market makers in the sense of on-ramping and off-ramping services from other economic systems, other cryptoeconomic systems, Ethereum, Litecoin, whatever, Solana, but also the fiat system into the Bitcoin system. They provide a marketplace for users to exchange Bitcoin tokens for other crypto assets or fiat money. They have a lot of market power. They make or break the kind of the market. and they earn transaction fees on all Bitcoins bought or sold on their marketplaces. Obviously, they have to comply with national regulation, but they also have to comply with the rules of the Bitcoin network in the on-ramping and off-ramping interactions with the Bitcoin blockchain network. Very similar to exchanges, merchants are also market makers. Any merchant that accepts or declines Bitcoin has an influence of Bitcoin on Bitcoin adoption as a method of payment. So they have market power by allowing users to pay with Bitcoins or kind of deactivating Bitcoin as a method of payment on their marketplace. So whether or not merchants adopt Bitcoin, whether or not merchants are allowed to adopt Bitcoin because of national laws could widen the customer base by and also the demand for Bitcoins. External policymakers, I already mentioned it before, they set the external boundaries of where Bitcoins can be used. They were not relevant in the early years. They're very relevant now since Bitcoin has become this big thing. And we have seen this year with the approval of the Bitcoin ETF in the United States, the prices of Bitcoin has skyrocketed because the Bitcoin ETF means institutional demand for Bitcoins. And this has increased demand from Bitcoins from a completely new customer base and obviously also influenced the price of Bitcoin, but also the profitability of running a mining node, for example. Electricity providers, very similar to hardware producers, provide an input factor for the overall network activity, especially mining. They influence the electricity availability and the market price, and therefore also the profitability, as I said, for Bitcoin mining. And here two factors are important. On the one hand, kind of the electricity price, but a thing that is also very interesting and counter to the mainstream narrative of Bitcoin being so energy intense, Bitcoin mining is often used to balance grid operations and guarantee load balancing activities where grid operators have excess energy. Bitcoin mining could be used for load balancing, which is very important in energy markets as well. Right, I'm going to look at the time. All right, so this is the last third. We've talked about the properties of Bitcoin. Let's look at the economic policies a bit more in detail. Because of its property of being a fungible asset, it is a currency. Bitcoin has a monetary policy attached to it, right? Bitcoin's distribution and supply is regulated in the protocol and was defined before Satoshi or by Satoshi before the protocol was first implemented and deployed. The first Bitcoins were minted in the Genesis block in 2009 by the first miner, a mining node operator, who got awarded with the Bitcoins. All newly minted Bitcoins were and still are rigidly distributed via the process of proof of work every 10 minutes to the winning miner. No tokens were ever pre-mined or distributed to founders or investors, as was the case with many ICOs or many DAOs today that do some fundraising. They have a treasury, they issue some tokens, they earmark these tokens for certain purposes to be spent later. This is not, this is very often criticized of being centralized. This was never the case with Bitcoin. As for economic policies, we will have a look at these 5 policy tools: the monetary policy, network taxes, policy changes, treasury and resource allocations, and proof of work difficulty adapters. So the number of Bitcoin limited to 21 million, and it's rigid. It's not adaptive, and therefore the price cannot be, the exchange rate cannot be manipulated either because it is very rigid. That has advantages, but it also has the disadvantage of not being able to maintain a stable exchange rate. The number of Bitcoins issued per block was designed to decrease by 50% every 210,000 blocks, approximately every year. And the last halving of block rewards happened a month ago. And the last Bitcoin is estimated to be minted in 2140, when the block reward drops below 1 Satoshi. And it is unclear what will happen beyond that point. Really, it is unclear. And it is assumed that transaction fees that are paid to mining node operators will still secure the system, but honestly, it is still unclear. And it really also depends on the price of the Bitcoin and the demand for Bitcoin. Token supply is fixed, it's rigid. The decreasing issuance rate is assumed to lead to a deflationary price development if Bitcoin gains value, and if the demand for Bitcoin surpasses the supply of newly minted Bitcoins minus Bitcoins, sunk Bitcoins that cannot be exchanged anymore. Beyond monetary policy, we have also to look at the network taxes, or AKA what I would like to refer to as fiscal policy. Mining node operators also collect transaction fees. These fees can be considered to be something similar to network taxes, only that these taxes are not paid to a pool, which is often the case in other DAOs or on a nation-state basis. Taxes are collected by kind of the nation-state representatives or institutions, and then distributed to certain stakeholders in a nation-state. The same is true for many DAOs that were created after Bitcoin. But in the Bitcoin network, these taxes are also, the payment of taxes is more decentralized, is paid directly to the mining node operator who gets rewarded, who collects the block reward. So it is not paid into a common tax pool, but it can be considered something like a distributed tax. The fees can be set by the user who initiates the Bitcoin transaction, and as I said, it's directly paid to the miner. Miners tend to prioritize transactions with higher fees because this increases their potential earnings. In theory, it is possible to send Bitcoins today without paying a transaction fee, but the question is if and when a miner will accept it in their block. And this is where fee markets have developed not only in the Bitcoin network, but also in other blockchain networks. So people who are willing to pay more fees get preferential treatment by the node operators. So fees are very often determined by urgency of the transaction, network congestion, transaction size actually, and the general market conditions such as Bitcoin's exchange rate. Monetary policy changes in the Bitcoin network, as I said, they're not provisioned for. There is no provision to, for example, adapt the exchange rate so it is stable against a different currency. Changing the monetary policy of the Bitcoin network is theoretically possible, but it's very unlikely because it would require the social consensus of all mining node operators, who would probably not profit from issuing more Bitcoins, unless certain market dynamics, unforeseen and market dynamics unfold. So theoretically, it's possible, but it is very unlikely that this monetary policy will change. As I previously also mentioned, treasury and resource allocation is not centralized. There was never a centralized treasury to fund, for example, ongoing operations, ongoing research in the Bitcoin network or development. The network was built by a community of voluntary contributors for free. Marketing services were done over social media for free out of sheer enthusiasm. Code development and development and maintenance in the early years was done for free and now is done by paid interest groups, I would say, and less by voluntary code developers. So this has become, this is a stronghold on one hand, or a point of decentralization of Bitcoin, but it is also kind of stumbling block for ongoing research and development, because in the absence of kind of protocol incentives, there is kind of the market dynamics rule, and the people, special interest groups with big Bitcoin holders can fund protocol development to pursue their own best interest. And power asymmetries arise. We also have the proof of work was designed with a so-called difficulty adapter that is determined by a moving average targeting an average number of blocks per hour. If blocks are generated too fast, the difficulty increases. If blocks are generated too slow, the difficulty decreases. This is to compensate for increasing hardware speed. So this was kind of far-sighted kind of economic design from the get-go to compensate for potentially increasing hardware speed and varying interest in running a mining node. Because Bitcoin is permissionless, anyone can opt in and opt out at any time. So there is no network kind of capacity planning, because people can just go online and offline at any point in time operating mining nodes. So you need an automatic adapter to compensate for this increasing increasing or decreasing network activities, while simultaneously deterring potential network attacks, or what we refer to as 51% attacks. To close, the analysis, what was Bitcoin's purpose and what is the reality today? When it comes to double spending, so we will look at 6 factors: double spending, peer-to-peer electronic cash, fees, privacy, economic assumptions, and stakeholders and power structures. When it comes to double spending, we can really say Bitcoin absolutely nailed this one, right? It resolved the double spending problem over the internet in the absence of trusted authorities. Bitcoin also sparked the renaissance of peer-to-peer network development, and what many refer to as Web3. So this one, thumbs up, Bitcoin really nailed this one. Now, when it comes to peer-to-peer electronic cash, peer-to-peer, yes, but only in theory. The emergence, as I said before, of centralized exchanges and the acceptance of Bitcoin by traditional financial system has re-intermediated Bitcoin. Since most people today who buy Bitcoin buy their Bitcoins on centralized exchanges, they don't own their private keys. So when they send Bitcoins, they store Bitcoins, save Bitcoins, or send BTC. They usually do it through hosted wallets, and this is basically using crypto through banking services. So it's not in practice. Bitcoin, unfortunately, is less and less used as a peer-to-peer system, even though it could be used as a peer-to-peer system if you would control your own private keys and have your own wallet. Is it peer-to-peer electronic cash, even if you own your own wallet? No, it's rather e-gold. Why? Because Bitcoin is not practical for everyday payments, because it's fluctuating exchange rate. It's very, very volatile. For medium exchange to be a practical medium exchange, you need some kind of exchange rate stability. And since the monetary policy is so rigid, this purpose was not met. And this has sparked a lot of innovation in the stable coin or stable token kind of category. And we have seen a lot of innovation since 2014, 15 until today. especially throughout DeFi summer, when it came to innovating stable token systems to mitigate for this insufficiency of Bitcoin's original design. Fees. This is a bit unfortunate as well. The aim of Bitcoin's founders was to reduce the transaction cost of sending money, especially for international transfers and for micropayments. This was true in the beginning, but right now the average transaction fee is very, very high, much higher than originally anticipated. And this is due to unexpected level of Bitcoin adoption and Bitcoin speculation, combined with a rudimentary monetary and fiscal policy that does not allow for flexibility to have economic, flexible and more flexible economic system. Yes, it's more decentralized, but it's also more rigid and less flexible. So Bitcoin is not viable for most day-to-day remittances, not only because it lacks a stable exchange rate, but because the fees very often surpass the actual payment you want to make. You want to send 20 euros or Bitcoins in exchange or worth 20 euros or $20 over the network, and might have to pay 80 euros or 300 euros in transaction fees. That does not make any sense. Privacy, we've talked about this issue for several times as well. Bitcoins are pseudonymous, they are not anonymous. They can be sanctioned at the edges of the network where the permissionless network intersects with centralized exchanges. Unfortunately, Bitcoin lost its pseudonymity or pseudonymous features through centralized on-ramping and off-ramping services like exchanges, and is therefore less censorship resistant and less fungible than initially intended. In practice, it's less censorship resistant and less fungible than initially intended. Satoshi addressed these privacy issues and proposed workaround solutions. However, these workaround solutions turned out to be insufficient. And in the light of chain analysis power that emerged over time, other blockchain networks came that tried to create peer-to-peer payment networks that were much more privacy preserving, starting with Monero, Zcash, and everything that followed. Unfortunately, today we're saying that these efforts of creating these private cryptocurrencies are often sanctioned by many governments, directly or indirectly. When it comes to the economic assumptions, Bitcoin has never been manipulated. The network transactions have not been manipulated to date, not to my knowledge. So the economic assumptions hold. But unfortunately, the economic assumptions upon which proof of work was conceptualized seem to have built on simple game theory, not collaborative game theory or game theory that includes behavioral economic assumptions, because people are not always only profit maximizing. As a result, the Bitcoin network has become much more centralized system than originally intended, especially through because of the fact that mining pools have emerged over time, where individual miners created mining cartels by creating a pool of miners to have a competitive advantage of validating more blocks and gaining more block rewards. So some argue that the reality of Bitcoin today, Bitcoin's consensus mechanism, proof of work, can be described something as a delegated proof of work, because mining pools are in the end delegation systems, where kind of the vote over, which transaction is valid or not is delegated to the mining node operator. And so the system has in practice become much more centralized, or an oligopoly of a handful of mining pools and hardware producers. And this might not reflect the original intentions of Bitcoin's creators. And to end it, when we look at the stakeholders and the power structures, we can analyze the following. The Bitcoin white paper only envisioned two types of node operators, mining nodes and light nodes. Full nodes and mining pools only emerged after the protocol was developed. They were never accounted for in the economic calculation or in the design of the incentive mechanisms. Chain analytics companies, they emerged later. They very often work hand in hand with government agencies and undermine the pseudonymous the privacy features, the pseudonymous privacy features of Bitcoin, and make it less fungible. Full node service providers and wallet as a service providers have emerged and have re-intermediated Bitcoin as a financial asset, which was supposed to be a peer-to-peer financial asset. So the emergence of all these unanticipated stakeholders, from full node operators, mining pools, chain analytic companies, wallet as a service providers, full node service providers, the emergence of these stakeholders changed the political and economic dynamics of the network and also greatly influenced the power structures within the network. And when we analyze the power structures, we can look at different levels of power: executive power, policymaking power, voting power, market power, and information and coordination power. On the level of executive power, as opposed to other Web3 networks, the Bitcoin network has very limited functions, which are predominantly executed by mining node operators. Even though we have many stakeholders in the system, only the mining node operators get to vote over protocol update and get rewarded and have the actual executive power to create new blocks of transactions. In terms of policy-making power, the case is similar. In theory, anyone can make Bitcoin improvement proposals. In practice, as I mentioned before, only relatively few people globally have the know-how to do so. If you go on GitHub and look at the GitHub commits, only around 300 protocol developers are more or less actively contributing to Bitcoin's improvement or protocol upgrade. But millions of people are using it, and billions in the future will be using it. So how decentralized is a system if only 300 people co-develop the system which billions use? Given the global population that could use it, let's say. And Bitcoin, as I previously mentioned, lacks this native mechanism to incentivize protocol development, and this has created a lot of power asymmetries. Private companies today, such as mining pool operators and big Bitcoin holders, have the economic power to fund the protocol development in the pursuit of their own best interest. When it comes to voting power, also, as previously mentioned, mining node operators can directly decide over protocol changes. In mining pools, depends on the agreement that the mining pool co-investors have with the operator. They may or may not have voting rights this is co-decision-making power when it comes to protocol upgrades. So this is unclear. Bitcoin holders have no direct possibility to vote over protocol upgrades. They can only coerce the miners via a user-activated hard fork or soft fork to accept a protocol upgrade, which they otherwise wouldn't, through their sheer market power. But this would require a lot of coordination among users and also technical know-how, and only users, of course, who have host their own wallet. When it comes to market power, Bitcoin holders have the market power to enter and exit the system. They make and break the market. Mining node operators and wallet developers have the market power over transaction fees. Merchants and exchanges, as previously mentioned, make or break the market via accepting Bitcoins as a medium of exchange, or by listing or delisting Bitcoins, accepting or not accepting Bitcoins. Policymakers have the coercive power over the citizens, residents, and companies to accept, to use Bitcoin or not to use Bitcoin. And obviously hardware producers and electricity market also have market power. Last but not least, and this is really the last slide, information and coordination power. The community dynamics of when it comes to discussing protocol upgrades in the Bitcoin network are very similar to public discussions in traditional media or on social media in the context of regional or national elections. The Bitcoin community, I think, lacks enough institutionalized mechanisms to make sure that all voices are heard. This leads to a fact that very often only the loudest voice in the chat room is heard, whether it's on Twitter or on Farcaster or on any other social network. Some people are very loud, but really kind of institutionalized communication is still not widespread, let's say. Everything is transparent and out there in public channels, but it's unclear to most Bitcoin holders, I would say. It is intransparent, even though it's open and public. And so if a certain group of stakeholders in the Bitcoin network can coordinate better than others, they can pursue certain policy changes in their best interest because they have the information power and the coordination power that other people or interest groups might not have. I would argue that there is still a Wild West culture in crypto in general and in the Bitcoin network in particular, which is mostly driven by those who have a certain tech know-how, certain financial know-how and power, or the loudest voice in the chat room. All right. I think I went much longer than I initially wanted, so I'll give you back to you guys. I'm sure that a lot of questions have come up, and maybe I will stop sharing the slide.
Yeah, first of all, thank you. What a wealth of information. I mean, this inspired a lot of questions and great thoughts in the chat, and I guess just going over all these aspects is super interesting with all the emerging elements that didn't happen or weren't created by design, and that's just something to keep in mind. Okay, applause in the chat. Let me digest the questions and let's pick up some of them. Okay, Jima asked, does this Wild West culture not reduce how decentralized we envision the Bitcoin network to be? Reducing decentralization because of the Wild West culture.
I mean, this is a philosophical question, right? So some people who tend to be more on the anarchistic side, they might deem this the right environment because it's like the survival of the fittest, and it's a Wild West culture. And if you want to be active, you can be active. You just have to make space for it in your life and be loud enough in the chat room, right? Other people with different political kind of aspirations or political philosophies might argue that this is too anarchic. This is too it doesn't help the people who, with less information, with less time to get the information needed to make qualified decisions, right? So it is since the Bitcoin network is a social and economic system, it is prone also to personal politics and also the personal point of view of what good politics is, right? Or what good policy making is and what good processes are in a network.
Okay, we have more questions. First of all, Susie mentioned loving this walkthrough and it's available as public goods. Yes, we try hard to make all this knowledge and education in token engineering available to as many people as possible. Thanks for noting. Aaron asks, zero fee transactions may only occur if a cooperative group of miners agrees to support the network by including zero-fee transactions. Do you see this happening for any purpose in any shape or form in the near future? If a philanthropic mining pool like that had emerged, can a user configure their wallet or node to connect to the nodes operated by a specific mining pool? Is this technically doable?
I'm not. Unfortunately, you would have to ask Bitcoin, somebody who is more into the technical details of Bitcoin. I cannot answer this, right?
But then for
what
the
I do know is
zero-fee
the
transactions?
only thing I do know is that in theory, you don't have to set a fee. Whether or not it is included in the next block or in a much later block, it really depends on network congestion and the general conditions. Unfortunately, but there is another thing that I don't know, most of you probably already used a wallet, so or even on your ledger or your other hardware device. You have to set a fee when sending, and it says high, medium, or low. It doesn't say no fee. So the wallet developers in their interface, by design, most of the time, I've never seen the option of no fees. I'm not saying it doesn't exist. I haven't used all the wallets out there, right? If you can, you operate command line and you know the Bitcoin blockchain, you can do it without no fees. I'm not sure what the reality of no fee transaction at the moment is.
Yeah. Okay. Let's take a look. Here's one more on the regulatory legal part. Regarding the regulatory legal framework to consider in the token design framework, is it that important to consider, since for Bitcoin it does seem that the founders didn't care much about it except by remaining anonymous. In the worst case, the protocol can be modified if needed in case of specific regulation. So is it important to worry about regulation?
Today? Yes. I mean, you don't... I mean, please read what is happening at the moment. So many developers are getting arrested in different blockchain networks. No, regulation today is a factor. You know, in the early days, it was such a fringe phenomenon. It was not a factor yet, but obviously regulation, there is a reason why Satoshi stayed anonymous and even went offline after a while. I assume, right? So protocol changes. So the Bitcoin network is the only or one of the few really decentralized and autonomous organizations. There is no centralized, like as opposed to Ethereum that still has a foundation and there is a very visible original founder and very visible core developers. The Bitcoin network is more decentralized, but the core developers are known. If national regulation wants to ban Bitcoin, they could ban Bitcoin. I think that at this point in time, for the United States to sanction Bitcoin is not realistic after an ETF approval, because a lot of people would lose a lot of money, including pension funds. So they could try to influence Bitcoin through, I think that unfortunately, with this Bitcoin ETF proposal, big financial institutions are becoming the big stakeholders in the network and might influence future protocol development. So I'm much more worried about that than national regulation in the case of Bitcoin. In the case of other cryptos, it's different.
Okay, I have another question on the stakeholders and the exchanges being stakeholders of a network. Question is, can an exchange be an internal stakeholder, or does it always belong to external stakeholders? For example,
this internal, external is a bit fuzzy, right? Actually, it's not really exchanger. are never really external, because in order to, an exchange always has to operate a full node, or usually more and more exchanges, they used to operate their own full nodes, and even exchanges have outsourced their wallet management and full node management to specialized service providers. But as a full node operator, actually an exchange technically is an internal network actor, right? But I put it at the fringe of the network because it's also, it offers the on-ramp and off-ramp services. So with exchanges, it's a bit tricky, yeah.
Okay, I think since we are at past, I would suggest we now say some more words about the homework, because you probably know everybody who is following this study season live track has the chance to acquire a proof of knowledge for the token design thinking framework. And we'll ask you to work on a case study and submit a case study. And then you either pass or don't pass. I mean, I guess with these brilliant instructions, you will pass, but this is the homework, and we'll share all the details in the chat. But maybe, Shermin, let's give an overview of what you expect. And the due date, submission date for this homework is in 2 weeks, right? We pause for 1 week next Friday. And the final session...
No, the submission date cannot be next Friday, because I have to look over it, right?
Yeah, let me check.
But yeah, you have like maybe 2 days before.
Yeah, yes, you're right. Homework due date is Friday, May 24th. So actually it's in 1 week. And yes, we'll have presentations of the results, praising those who submitted, and discussing the results on Friday, May 31st. Always same time as today. So you'll have now 1 week to work on a dedicated case study and apply and use the token design thinking framework yourself.
Yes. So Angela and I were discussing before which use case to analyze. Mm-hmm. And because you guys have been also working with the use case of Ocean protocol, and because Ocean is it's quite an intuitive example, but it's also very different from the Bitcoin example, because it's a 5-token system. It started out as a 1-token system, and at the time right now, if I'm well informed, it has 5 different tokens. So it's a very different use case, and it makes sense to analyze it as a kind of counterpart to, or as complementary to Bitcoin, to have a different purpose and at a different use case with different types of tokens. By tomorrow, I will post on in our chat the exact kind of slides, or kind of the questions that you should focus on. You don't have to analyze everything. So I will give you a guideline. You should work in teams of 2 or 3. So Fabi and Angela can maybe coordinate this, who should work with who. So I'm not involved in that. And I would ask you to send a PDF or a link to a Google Drive, but it should be presented as slides, and use case, functions, stakeholders, and the tokens, and the token types, and the properties of the tokens.
Mm-hmm. There is one question, I think that's a relevant one in the chat. Can we submit the case study about our own projects?
So I think we were thinking of doing that. It's too much. I mean, if you want my feedback on your own case study, we don't have enough time, right? This would be a whole day workshop only on one case study. The reason we thought of doing that, but it's not feasible in the given time that we have, and in the time that I also have to read everything. The reason we chose one use case was because then whatever you're working on, we will select one group to present, and then we will discuss something that everyone analyzed, so you can compare notes, the conclusions you came to, right? And so this makes sense. This is a better learning experience. Otherwise, it's everything else doesn't work so well. I've already tried it in different workshops. So of course, you're welcome to take the design thinking framework, apply it to your own use case, because that was what it was designed for, but not as a homework.
Right. And I'll promise going over a given case will give you so much experience and insights about how to apply this to your own case.
Yes.
It'll be definitely valuable. All right.
Yes, especially because Ocean really will give a lot of insights to 5 different token types where each different token type has a different purpose. And this will be, I'm sure this will be quite insightful for whatever you're building yourself. Yeah.
Okay, so stay tuned. Watch the Discord for further instructions, deadlines, links. We'll provide you with everything. And of course, feel free to drop us messages in case you're missing anything. And we'll meet again in 2 weeks on Zoom. Again, submission date is in 1 week for the homework. And yeah, it'll be pretty exciting to see the solutions and to discuss your thoughts about this token model to analyze. Thanks a lot for today, Shermin. It was just a wealth of knowledge again. Thanks for sharing. And thanks everyone for attending the session and following on YouTube or Twitter. See you in 2 weeks.
See you. Thank you.
See you in 2 weeks. Have a nice weekend. Ciao.
Thank you so much.
Yeah,
Thank
ciao.
you. In case you guys are around in Berlin Blockchain Week next week, I'll be there. See you there at
Okay.
DebCon minimum. Bye.
Bye.
The recording has stopped.